Now we're going to look into density. Density determines behavior. The numerical value of density determines whether or not it will float or sink in another material. For instance, cork has a smaller numerical value of density than water, which has a smaller value than brass, which has a smaller value than mercury. And so cork floats in water because the numerical value of density is smaller than that of water. Water has a density of 1 gram per milliliter, and brass has a density of something like 4 grams per milliliter. And then liquid mercury has a density of around 13 grams per milliliter. And it is that numerical value that allows you to predict whether or not something will float or sink in another material. Density is a mathematical relationship. Density is defined as mass over volume. In order to determine the density of a substance from its mass and volume, all you do is you take its mass and you divide it by its volume. Now, we usually express solids and liquids in grams per milliliter or gram per centimeter cubed. However, density can be expressed with all sorts of units. The metric system defines the density of water as being 1 gram per milliliter. At 4 degrees Celsius, it is exactly 1 gram per milliliter. And at temperatures, room temperature and above freezing, the density of water is very close to 1 gram per milliliter. And usually we just say the density of water is 1.00 gram per milliliter, pretty much at all temperatures at which we might deal with it in a laboratory. You are expected to know the density of water. All of the constants for water will be considered something that you need to know or have memorized. Now, specific gravity is used in the medical area. It is not used in the science fields where we do research much, but specific gravity is used in the medical area. Specific gravity is a way of expressing density without units. And what they do is they take the density of the substance and divide it by the density of water at its same temperature. But remember, the density of water at temperatures at which we usually are in, at room temperature, let's say, is 1 gram per milliliter. So basically, you just remove the units from density and you have its specific gravity. To convert specific gravity to density, add gram per milliliter as a unit. Density can be used as an equivalency. Now, we're going to be doing mass to volume and volume to mass conversions that require the use of density. Many of you have learned in science classes to use the equation density equals mass over volume and to plug in your knowns and do a mathematical, an algebraic rearrangement and solve for your unknown. That's the hard way to use density, and many people often do their algebraic rearrangements incorrectly. A surefire way of using density and an easy way to focus on units is to convert the density of a substance to a fraction and use it as a conversion factor. Notice right here the density of ethanol is 0.79 grams per milliliter. Because per means divided by, I can express it like that. That looks just like a conversion factor, doesn't it? It is a conversion factor. I can take that and I can turn it over and it will still be an equivalency statement because these two things are equal to each other for that substance. I can write my fraction like this, or I can write that fraction like this, and it's still equal to 1. That way I can use it to do conversions from either volume to mass or to do mass to volume calculations. Here's an example. 22 grams of ethanol. I can take the fraction and figure out how many milliliters that is because I need grams to cancel. I take my density and turn it over so that grams is in the denominator. Grams now cancels out and I get milliliters. So now what I would like you to do is to try this problem. Pause the lecture and do this problem, noticing they give you a density, 0.53 grams per centimeter cubed, and they give you a mass. You never start your calculation with a relationship. You always start it with a measurement. And here's your measurement that you're going to start with. So pause the lecture and set up this problem to get the volume of the lithium metal.
The first thing that we need to do in this problem is write down the given. The given is the number that's given in the problem. Now, density is not the given. That is a relationship. You do not want to start any problem with a relationship because oftentimes it will give you upside down units. So we start with the given, 43.5 grams. Next, we're going to make sure that grams cancels out and we go to a unit of volume, centimeter cubed. In order to make this fraction equal to 1, I look up in the problem and I see that 0.53 is written with gram in the density. So I will put 0.53 with the unit gram. Now I enter this into my calculator and I come up with 82 centimeters cubed. Do is convert kilograms to pounds so that my dosage will be in units per pound. Notice kilogram is in the denominator, so I must have kilogram in the numerator in my conversion factor. I need to make my fraction equal to 1, so I will be entering 2.1. It's with pound in this equivalency statement, so it will need to be with pound in the denominator of this fraction. I need to now multiply by the mass of the patient, and when I multiply by the mass of the patient, you see kilogram and kilogram cancel out, pound and pound cancel out, and you end up with only units. Now this may seem like a really large number, but typically heparin is given in large numbers of units when given to patients that need it.